Hi, this is a basic tutorial about tilted solids. A quick disclaimer. I am well aware that there are other methods taught by teachers and draftspersons. However, I teach according to the method that best suits my preference and is based from experience by observing and interacting with students over many years. If you prefer a different method and it applies to the rules related to the content, you are welcome to do so. In this tutorial, we'll be discussing a pentagonal prism. On the left-hand side, you see an isometric view of a pentagonal prism. In the middle is a slanted or tilted solid, which represents the pentagonal prism at an angle. On the right, we have an oblique view of the pentagonal prism. If you draw the isometric view of the pentagonal prism, you will understand that the base of the pentagonal prism is at an angle of 30 degrees, as shown in the illustration. The oblique view's base angle will rest on a 0-degree base, and then the slanted surfaces could be at any other angle, which can range from 45 degrees, 60 degrees, 75 degrees, or any other required angle. Here we have provided to us on the far left the top side of our pentagonal solid or prism presented to us, and the top side is exposed. In the middle you see the base of the pentagonal prism or solid being exposed, and on the far right we see a 2D front view and top view of this solid. Just want to emphasize that the top part of our prism is over here, and here is the base of our pentagonal prism. We are going to expose the top side in this drawing that we are going to discuss in the tutorial. On the far left hand side of our page, we see our 3D preview of the pentagonal prism. So this is our 3D preview with the top side of the prism being exposed. So here is our top, and this here is our base. Moving on to the 2D views of the prism, we are going to start with the top view of the prism on the first example. And now we will look at the edge of the top view over here, and that will be represented by this area of our front view in 2D. These surfaces here and here represents the slant that we see over here and here moving away from us on the front view. On our next drawing, we have turned the pentagonal prism and we see our top view's corner here, and that is going to be represented with this line on the front view. Here we have a slightly slanted surface of the pentagon, which is represented in this area, and then we also have the slanted surface that's a lot more angled away from us over here. On the third drawing or example of the top view, we now have the tip of the pentagon showing right at us, and that's represented by this line. And then we have two equal angled sides that is going to move away from us, like you can see here. And the last one that we have, the fourth example, where we again have our top view. Now we see the tip or the side or corner that is closest to us over here, and on the front view this line will represent that corner, and the slightly lesser angled side here will be this part seen from the front in 2D, and the more slanted surface, which is over here, will be being presented by this grayed area on our front view. Here we have the page layout of our actual question. On this page we will see at the top left our question section. Then we will see the 3D preview of the model. We will also notice the front view of our model and our auxiliary view of the model over here. We will be drawing in the answer for our top view in the space down here, and we will also draw in the right side view of our model in the space over here. And finally, we will end off with the true shape in the space provided here. We know that this is a first angle orthographic drawing because our first angle projection symbol is given at the bottom right. If you are not familiar with first and third angle orthographic projection, you are welcome to look at one of my other YouTube tutorials which clearly explain the difference between first and third angle orthographic projection. For the remainder of this tutorial, we're going to assume that you do understand the difference between first and third angle orthographic projection and where views are placed in each of these projections. Let's take a closer look at the question. It says the following. The provided model on the right shows the front view, so let's highlight the front view, and the auxiliary view of a right regular pentagonal prism. The next part of the question I'm going to just erase for the time being, because we will discuss a cutting plane through the same model in a later tutorial. The rest of the question, we read that we need to have a right view and a top view, and finally we need to construct a true size of the prism to the x3y3. Here we have an overview of the answer that we are going to attempt to explain. Here we have the front view provided to us on our print. We also have the auxiliary view as discussed earlier on. We will have our right side view over here. We will have our top view here, and finally the true shape here at the bottom. Our x3, y3 is the angle at which we will see our true shape. I have already labeled the corners of my pentagonal prism on the front view and the auxiliary view. You will not always receive the corners labeled for you, and then you will work out your own system to label the corners for your prism. But a good idea is to always start labeling at the auxiliary view, and it's also a gentleman's agreement to label in a clockwise direction, although it's not wrong if you want to go anti-clockwise. But it is important that you start labeling the corners of your prism at the auxiliary view. It will just make life easier for you in your projections later on. We will start answering our question by drawing the top view first. In order to do that, we need to go to our front view and project from the corners of our front view the vertical light construction lines down to the top view. Therefore, I'm going to go and start from number 1, 2, 3, 4, and 5 at the top part of my pentagonal prism and project the lines vertically straight down towards my top view. And these lines are indefinite in length, and it's rather better to make them too long than too short, and you can always erase the excess lines afterwards. We will do also the same for the base end of our prism and project the corners of the base end also down to the top view perpendicular towards the x1, y1. Once you have done the projection lines from the front view to the top view, it might save time later on if you use the same principle now to project from your front view the construction lines of each of the corners of your prism towards the right view. And that will just help us with our measuring when we get to the right view later on in the tutorial. But it is your choice whether or not you want to do these projections now or only once we start doing the measurements for our right view. But please keep in mind that they are also light construction lines and that they are perfectly horizontal and projected from each of the corners to the right view. Once we have completed the projections from our front view to the top view, we are going to draw in the top view. We know that the top view is going to be placed in the space below the x1, y1. We also know that we are going to use our measurements from the auxiliary view and carry them over to the top view in order to complete the top view. And we do that because our rulebook teaches us that we need to use the principle of measure, skip, measure. And the principle of measure, skip, measure comes from points and lines. And you can find very good tutorials on YouTube made by teachers and instructors explaining the principles and construction of points and lines, which is the prelude to solid drawings. Therefore, we also need to understand our rulebook that teaches us that the XY separates different views from one another. And if we understand that rule, we also know that the projection from one view to another over the XY must be at an angle of 90 degrees to the XY. Once we have now completed these projection lines from our auxiliary view to the front view, we can start our measurements using the principle of measure, skip, measure. Because we want to draw on the top view, we want to now measure from the auxiliary view. That means I'm going to start with corner number 1 of my pentagon in the auxiliary view, and I'm going to measure from the projection of the XY to number 1 and measure that distance with my divider. Because it has two sharp metal tips, it is the most accurate tool to use. Once I've measured the distance from the XY to number 1 on the auxiliary view, I follow the path of the projection to number 1 on my front view, and then I will also follow that path all the way down vertically to the top view. Once I've reached the XY, I know that I need to measure the distance of number 1 that I've measured at the auxiliary view and carry that over now onto my top view. And I will immediately place a dot on my top view and label that dot right away. It is a good practice to immediately label a measurement that you have carried over. Otherwise, you will end up with a lot of dots and you will not know which one belongs to each label. This we will now continue to do with all the other corners of our prism, which is number 2, 3, 4, and 5 in the example of this pentagonal prism. And we will measure all of them now from the XY on the auxiliary view. Follow the path then to the front view, and from the front view all the way down to the top view. It's also important to notice that now with our front view, we have the top lid of our front view, and there we will find the first 5 points, which we have carried over now to the top view at an angle of 90 degrees. And we also need to remember that the base end of our prism needs to be carried over to the top view as well. And that will also be straight down in the direction as shown here towards the x1, y1. And we will also make use of those same measurements that we use at the auxiliary view. Therefore, if I were to again use number 1, we will go to our auxiliary view and measure once again the distance from the xy to number 1, follow the path of number 1 on our front view and go down towards the top view, and then from the x1, y1 we will plot again the distance of number 1, which we carried over from the auxiliary view, and that will then be the base corner number 1 on the top view. In the next slide, we will show what the profile of our pentagon will look like in the top view next. Once we've carried over all the corners of our prism from the auxiliary view to our top view, we can connect the corners of our prism in the top view with one another. As you can see here, we draw like construction lines from the top to the base of our prism on the top view. This we do till we have completed all the corners and created a profile which we call the ghost view. We do not draw in any of the lines solid yet because we first have to establish which parts of the prism will be seen and which parts of the prism will be hidden if we were to look down onto the prism, and therefore we need to consider what we see if we were to move to the front view and look at the top lid and observe it from the top down. Because we are busy drawing the top view, we are going to observe the front view from the top down. Therefore, from number 1 to 5 and the area indicated now, we will see on our top view that the whole surface from number 1 to 2, 3, 4, 5 and back to 1 will be exposed and visible when we are looking at the top view. It also means that our outer edges of the prism on the top view will be solid because the outer edge of an object will always be drawn in solid, and then number 1 and number 1 is seen first when looking down on the top view. So if I were to go back to the front view, look down onto the front view, I will see the corner number 1 of my prism first, and therefore we know that 1 and 1 on our front view and top view will be solid. Here we have now drawn in some of the outlines of our top view with solid lines. We will make sure that these lines are drawn neat and accurate using the correct pencil. Once we have completed drawing the outlines of our top view solid, we need to determine which parts of our prism will be hidden. Therefore, we need to move back to our front view and observe the front view from the top. If we do this, we will notice that the base of our prism is not visible if we were to look down on the front view. That means that corners 3 and 4 will be completely hidden when we look at the top view. Therefore, because number 2 and 5 were on the outer edges, from 5 to 4 will be hidden in our top view, and that we will now draw in properly in the next slide. We have completed all the hidden detail for the top view, and we will move on to the right side view of our model. In order to draw the right side view, we need to observe the front view from the right. This will help us to determine which parts of our right view will be hidden and which parts of it will be shown in full. We also need to start with our projection of the right view exactly the same way that we did with the top view. And that means we will need to start with our auxiliary view, and we are again going to apply the rule of measure, skip, measure. Therefore, we're going to start with number 1 in our auxiliary view and again measure from the XY to number 1 with our divider. We will follow the path of number 1 across the front view, and then we will start our measurement from the X to Y2 and apply the measurement from the auxiliary view onto our right view, and we will plot the dot for number 1 in the side view, and we will immediately label it as number 1. This we will now continue to do with numbers 2, 3, 4 and 5. That is all for the top lid of our pentagonal prism. Once we've completed all the 5 top points of our prism, we will move on to the bottom of our prism, and we will need to carry over all the base points of our prism to the side view. Therefore, we are going to again start with number 1 and project the distance that we carry over from number 1 on our auxiliary view from the XY onto our side view. Follow the track or the path, whichever you want to call it. From the x2, y2, we will place our divider at the intersection of our x2, y2 with the path, and we will carry over the distance of number 1 from the x2, y2 to number 1, plot the dot, and immediately again label the dot. Please notice that the distance for number 1 of the top part of the prism and the bottom part of the prism is the same. And we will continue this process till we've carried over all those points from our auxiliary view onto our side view. Once all of the corners of our prism is carried over onto our side view, we can now draw in all the lines that connect those corners to one another, and this will create the profile of the ghost view for our right view. Once we have done the ghost view, or the profile for the right view, we can determine which parts of our side view will be solid and which parts will be hidden. Here you can see all the solid lines of our right side view being drawn in. Just to make sure you understand why we have drawn the full surface of our right side view as given here, I want to highlight that we are looking at our front view's top lid from right to left. And because this is the surface that we see first, we know that in our right side view, this whole profile will be seen as one full surface in our right view. And then the base will be hidden because numbers 1 to 2 and 1 to 5 will be hidden in the back when we are looking at the front view from right to left. Now we have all the hidden detail drawn in, and we have made sure that all the corners have been properly labeled, and our hidden detail, remember, has to be drawn in medium tone, and this will then complete our right side view. Our last part of the question is to complete the true shape in the space provided. Therefore, we know that the x3, y3 separates the true shape's view from the front view. And because we apply the rule book, which says that the projections must be 90 degrees to an xy, we know that we are going to do the projections from our front view 90 degrees to the x3, y3. And we will again return to our auxiliary view to get our measurements that we're going to carry over onto our true shape. Like we have done before, we are going to again use number 1 of our auxiliary view and measure the distance from the xy to number 1, and we will follow the path, which will now be slightly slanted from corner 1 all the way to the x3, y3. And then once we have reached the x3, y3, we will measure that distance with our divider carried over from the xy to the number 1 on the auxiliary view, and we will apply that now here on our true shape. Once again, we will plot the dot and immediately label that dot. This we will now again do with all the other corners of our prism, and we will do that for the top lid as well as the base of our prism. And once we have plotted all the dots and labeled them, we can now draw in the light ghost view or profile of the true shape. We now connect each of the corners of our true shape with light construction lines like we have done with the top and side view. This will give us the ghost view or the profile of our true shape. Once we have determined this profile, we can determine which parts of our true shape will be solid and which parts of the true shape will be hidden. Once again, we need to determine which parts of our true shape is going to be solid and which parts are going to be hidden. In order to do this, we need to observe our true shape from the front view in the direction of the x3, y3. And as the rule book describes, we need to look at it at an angle of 90 degrees. Therefore, in our front view, the top lid of our prism will be exposed if we were to observe the true shape from that direction towards the x3, y3. That means the full surface of our prism, as shown here, will be exposed when we look at the angle as provided from the front view. It also means that the base end of our prism will be hidden, and that means that corners 3 and 4 will be completely hidden in the background. And finally, once we have drawn in all the outlines and solid lines of our true shape, we can complete the drawing by adding the hidden detail as shown in this example. Thank you for watching the tutorial, and I hope to make many more tutorials where we can discuss the principles of technical drawings.